the panel discussion. I request all the delegates to be ready with the question. We'll go live in few minutes. So my first question is for Mr. Amit. You mentioned that IEC 62890 provides a life cycle perspective to managing instrumentation and control systems. So how do you see the standard practically influencing decision making during control system upgrades, especially in the brownfield environments?
Yeah, absolutely, and thank you for taking this. Basically, first of all, while we are taking any standard approach, which we talked during the presentation as well, it gives, first of all, a structured way instead of just ad hoc way to something has came and to react. So it is not reaction based, first of all. It is a strategic way, a planned way. You map the things, you have the data, and you know the risk of each and every assets. And based on that, you can schedule and you can act and you can take action. So in the management of change process, what we have, while integrating this is giving a different edge than doing the things in ad hoc manner. So, for example, there are strategies defined, the LSRM, last time buy-in, substitution, redesign, and migration. So we know exactly based on the profile of the asset, risk, etc., that how we have to go. We know the vendor profile. If we know the vendor is lacking at this place, then what strategies to take? So this is how it really helps to the users and users.
Thank you. My next question for Dr. Santosh. How can we accelerate AI adoption in industries with deep engineering?
Thank you. I think, like I mentioned in my presentation, any AI requires data. I think prominently most of us understand that garbage in, garbage out, and hence there has been tremendous focus in the industry for getting the data right. I think what we tried to explore, because we said that data can be erroneous, so we need to factor that in. How do we use human intelligence to basically ensure the data maturity, data versioning, right? Data management. I think data management, once you address the data management aspects, I think your AI can start scaling, and basically we can leverage the intelligence that AI gives us with the data we have, with the awareness that the data needs to be mature or it is immature and it is not correct, so that AI can then address or refine or moderate its response or take actions based on the maturity and the versioning of the data which we have at that stage, right? Because as time progresses in the project delivery, the data would mature, right? And then I can't wait for my AI to be deployed at the last stage, because I want to leverage or accelerate my project delivery using AI at the start of the journey. Hence, I need to train my AI to work with data that is not consistent. So hence, if we can start working on that, that would take us or improve the adoption of AI very early in the project and basically accelerate the use of AI.
Thank you, sir. My next question goes to Mr. Chandrasekhar. What are downstream and upstream requirements for effective use of AI in manufacturing?
That's a great question. So one of the precursors to AI manufacturing, again, Santosh alluded to it as well, we need to ensure that we harden the quality of data coming in. Now, let me give you a quick example. Let's assume that we're talking about a manufacturing industry where a lot of events are being generated in the course of manufacturing. Let's say we miss one event of hundreds and thousands that are generated every day. What happens, Amit? Yeah? So, yeah, that's an example. That's a very simplistic example, but to ensure that the right data is sampled at the right time from the right asset and it is not an overkill, these are all aspects of data engineering, which is the upstream. Data engineering is a very important part of leveraging AI. Now, upstream, ultimately AI has to have consumers. Now with the killing on the use of AI, maybe prompt engineering is a start point, right? And ensure that the fear of AI is taken out. So wherever I go to speak, one of the first things I ask people is, have you used AI? And a lot of hands don't come up. But when you say, have you typed something into Google, or have you, right, talked to Siri or whatever like that, everybody's hands comes up. So one of the aspects is, especially in a manufacturing environment, is to make sure that up and down the value chain, people are AI aware, people are data aware, and able, willing, and ready to use that.
Thank you, sir. Moving on to the next question, which is from Mr. Amit. What role does cross-functional collaboration play in successful lifecycle management of instrumentation and control systems, especially when dealing with obsolescence and upgrades?
Yeah, this is very important question. So the life cycle management is not alone the technical aspects. A lot of cross-functional and multi-stakeholder collaboration is involved. While such kind of business case is coming as a management of change, so there is multi-stakeholders. For example, if it is coming to engineering, of course, it will be looked the technical aspects, it will be evaluated on the risk front and other, but then our other stakeholders who is maintaining the plant, our assets and operating, they have certain perspective, even though if we are proposing something, what is also their perspective, what they wanted to say. Then we have our governance team, the risk team, they have also certain perspective. So if you look the financing, security, safety, a lot of teams are there who are part of this management of change. So more than technical, it is a cross-functional collaboration, evaluation, and then to come up the final alternatives and outcomes. This is very important. Thank you.
Thank you. Next question is for Dr. Santosh. Where do you see the biggest skill or mindset shift needed to make AI-enabled engineering systems a practical reality?
I think like Chandrasekhar mentioned earlier, today if you look at especially in the oil and gas industry, engineers have been trained to be risk averse, right? Because safety is one of the very important parameter for any oil and gas engineers. So with AI coming in picture, I think there should be some risk-taking ability. And if you look at the ways the chemical engineering or basically the engineers in oil and gas industry have been trained, they have been trained to think in terms of drawings, right? What is my drawing? This is my discipline. This is what I'll fit in. This is how the process flow works. This is how my piping works. This is how the line works. But then they don't talk about inter-collaborations or exchange, the data which I generate, how is the downstream discipline going to consume it? What decisions are they going to make? What risk it's going to introduce in the entire design of that particular refinery plant? So I think just moving away from design or drawing to data and risk insight, I think that is a big shift which every engineer should now start looking at. And like Chandrasekhar said, right, also looking at prompt engineering, right? We can always automate the prompt engineering with context engineering, etc. But then the engineers need to be trained that, okay, this is what the AI or agents have been asked to do, and this is what the data I get, this is the risk associated with this data, this is how I need to interpret the data or basically introduce the uncertainty that is generated from the data which AI produces. I think these are the two major skill sets where they need to change the way they have been thinking to basically say that how is my data going to be consumed by the downstream disciplines, and how can I basically take the data generated by AI which can have some inconsistency.
Thank you. My next question to Mr. Chandrasekhar. What makes your AI stack effective for stakeholders?
So a couple of things. One is, today, I think ChatGPT has popularized and made AI very accessible to people in a way that they can relate to it. For example, my wife was trying to use AI to check the vastu of some property. Okay. Then she looked up horoscope predictions. So it's made it very, the fear factor is going away. However, from a AI in manufacturing perspective, it is the last mile that matters a lot. It is the difference between, let's say, if you look at drawing detection, 99.9% versus 95% makes a huge difference. And that's where domain comes into play. The ability to ask really complex queries or automate certain agents to handle things that are, today not even envisageable, requires deep domain expertise. For example, we have application engineering knowledge in our group of literally every part that's in a two-wheeler or a four-wheeler or a three-wheeler or an engineering industry or an air compressor or things like that. Now that kind of knowledge mated with AI can provide inputs that are extremely actionable. So the domain expertise part, making sure that it is data engineered in a way that is accessible to the AI engine, and not only that, allowing for a customer's specificity to be layered on top of that as part of the architecture. So it isn't just that Ace Micromatic has a great AI. Now when my customer asks me, what can you do for me? I cannot just give them what I have. I need to give them the ability to layer their data, and in a way that we do what we do foundationally, the same thing has to percolate to their data as well. So these are the two aspects that I would talk about.
Okay, thank you. So moving on to live audience Q&A. Anyone has questions? Yeah.
Mike, please.
Hi. The question to is Micromatic. Yeah. So, sorry.
Please introduce yourself.
Yeah. Myself Shabri. I am from Siemens. So really, it's a Siemens. So it's a really impressive presentation, and your AI journey is also very impressive. So my question is, in your company, for your AI journey, you are using your own AI model or you are using LLM, right? And if it is LLM, how you are bringing your domain expertise contextual to LLM specifically?
Okay. So we have done both. We have our own AI framework, but we also leverage other AI frameworks as well, like Gemini, like Llama, like Mistral, and there are specific aspects built in each of these LLMs specific to each vertical. So we leverage both. Where a customer or where an ecosystem is able to leverage an outside connection, we tend to leverage the outside LLMs. But where it is proprietary data or people by confidentiality or by need to keep the data in-house, we run it locally. So this is how we do it.
Okay, next question.
My question is to Amit, that in your life cycle management plan, how you align yourself with OEM life cycle, because OEM, like you told during the presentation, that you have all the product, like all OEMs are installed in your setup. So how you align your life cycle plan with the OEM life cycle management, because they have their own product life cycle. And my second question again to Amit, that how you deal with this compatibility issue. So certain hardware you upgrade, you plan in upgrade, but certain hardware in the same line is not compatible what you upgraded. So
Yeah, so this is a common issue, and your question is, I think, globally applicable to a lot of end users. Basically, in terms of the first part of the question, I think you are asking how to align with the OEMs and vendors. So see, there is, I cannot say like it is 100% alignment, considering the fact we have some control. For example, if you are proactive, then you can extend life cycle up to certain extent, right? You can have some specific agreement if you are in between. But if you are in the initial stage of the project, I had shown the total cost of ownership and what. So that time also, if you are proactively working on the project, the contract, the way, you can optimize certain extent with the what kind of family, what kind of maturity product is getting offered from XYZ vendor, because in that phase you are evaluating. Rest, if you didn't do it, then you are in typical phase, which you can just optimize with some special agreements, or like if you have some modular tech available and if you can divide, but then you have to evaluate the risk. So depending on the scenario, it is again not a single answer for everything, but depending on the type of profiling, it can be decided. In some cases, yes, I can remove X vendor and I can put Y, but it is not possible for everything. So it will be contextual to the scenario. And I think second question, if you can quickly once again repeat. Yeah, so for the compatibility issue is again, it is a typical issue. While it comes to the upgrade, then of course, if we are in vendor lock-in, this is a generic issue, and organizations are looking into it, how we can be more open or more aggressive. Sometimes this aggression can be taken and have been taken in certain part, but depends whether the perspective is related to safety, monitoring, control. So if it is more on safety, it goes on conservative front, and then sometimes you have very rare to play here and there. But what we feel, this is where the push is happening, that how the system can be more open, how it can be leveraged more. Some vendors are supporting very well, some are still conservative, but the way technology is pushing, I think it has to go. So.
Sir, can you please introduce yourself before asking the question?
Ma'am.
Yeah.
My name is Sumit from NTPC. Sir, this question is to the honorable speaker at the center. Sir, your presentation was excellent. You spoke about industrial AI. I would like to ask, because, when you try to obtain know-how and inference, with the kind of inference which you are showing, it seems that your models would be becoming much more complex while you have implemented. So my question here is on interpretability of the model and its results, because generally the machine learning and these modules slowly and steadily with the increasing complexity tend to be black box. So, sir, how do you take care of that aspect? Because you make use of that in industry. You are also putting, providing solutions for your customers. So, how do you, convince them that that this is how exactly it will behave, and this is how it has been used, and there's nothing wherein the other factors are very less, actually. So I hope you understood what I'm trying to ask. Yeah, thank you.
Let me try to answer. It's a very interesting question. So if I understand you right, how do we explain the AI results that we are getting, in short, correct? Right, and make sure that it is actually right. So this is really a whole field of what's called XAI, explainable AI. Now it has far more significance in social context. For example, let's say when police departments use it to profile people, there's a lot of bias that comes out. So you need to have XAI that's very, very strong in explaining the bias or explaining why a certain prediction was done. Now in the course of industrial AI, it is still important. And one of the ways we do look at that is to make sure that we run concurrent modeling using pretty high-end statistics. Because ultimately, what is AI? AI or ML at every node is a mathematical expression that's calculating probability as an input to the next node, so to speak. So we build multivariate analysis, statistical models to make sure that at least the trend is similar. That's number one. Because statistics, everybody accepts, correct? Because you're just processing data. Now, whether it's ANOVA, remand, multivariate, all of that. Then we deploy a lot of LSTM. So there is always a memory that is embedded into the AI modeling so that the hallucinations come down. Again, I'm not the right technical expert to talk very in depth about what people do, but we deploy a lot of techniques to make sure that our AI output is not only seen as, good, but is actually validated as being good by feeding back this into other models as well, and not just relying on an AI model. And that's how we validate that. Does that make sense?
Good evening. I'm Keshamurthy from Aeronautical Development Agency, DRDO. My question is on the Industry 4.4 scenario, where we use AI for health monitoring of the machines. Now, more of AI means more vulnerability for data loss and also for hacking. So, how do you ensure the health monitoring is by AI is okay? Take, for example, turbine blade manufacturing. One machine fails and the indication comes to the program manager through AI, and the next machine takes care of that kind of thing. Now, in this scenario, if there is a loss of data or if there is a failure of AI because of the hacking, let's say, how do you take care of that?
Is that for me?
Yeah, this is for you.
So, again, a couple of things, sir. One is, I'll talk about two aspects of security, so to speak. One is to make sure that it is not prone to hacking or malicious malware affecting the data feeds, things of that nature. That's kind of an OT layer implementation, where you harden the IP schemas, you harden the security keys, cryptography, the data in rest, data in motion, all of that. That's one. The second is, to your question, let's say those things are taken care. Now, something happens where AI itself fails, the prediction fails. We typically tend to have at least one more stream that is getting processed, which is the so-called traditional streams. It could be predictive analysis using statistics. You look at coefficients of correlation, regression, some of these other parameters also, Pearson, Laplace, all of that, where if there is a huge skew between what AI is predicting and these traditional statistical methods, alerts actually go out. So people are aware that there is a skew that is potentially here. Now, is it right, wrong? Which is right, wrong? People need to figure that out. But at least there is a mechanism of alerting. Yeah?
Any more questions?
Okay, so thank you. Shall we give a round of applause for the speakers? It needs a lot of courage for speakers to speak in the last session, and I really thank them for speaking, and then all of you being here and asking the questions. So thank you very much for that. Before I conclude, again, an announcement for today. So we have dinner. We'll also start early, maybe around 6:30 along with cocktails. The hotel has agreed to support it. Those who don't want to have cocktails, want to have early dinner, they can have it. Second is, please fill up the feedback form to give it to any of the IRC members. It will help us. So one of the feedbacks was that we're having all the sessions in the main hall. So this year, after several years of thinking, we did a track session. So you can see the impact. The crowd got divided between three parts. Here, the other track session and the exhibition hall. So that's an impact. So we'll analyze the impact of it and decide what next. So we give the feedback. It will help us to think further. Third is, we have a heavily packed session tomorrow, starting from the morning. Presentations by MIT, NASCOM, Dr. Reddy's. We have, after several years, we have a presentation by a pharma company, Dr. Reddy's. We also have a sponsored presentation on OPAS, followed up by a presentation from speakers from Malaysia, from ExxonMobil. We have speakers coming from ExxonMobil USA. We also have presentation by Sunita, who is here, from Reliance. We also have presentations from OPF and OPA vendors. So tomorrow is equally heavy packed, possibly more end-user presentations than today, possibly only one sponsored presentation. So there will be a lot of learnings, a lot of exchanges. So please join us tomorrow. Thank you. From DRDO, we're very proud of your contributions to our society and the country.